Section: Introduction. In this section, we discuss the importance of understanding context in human speech, especially when dealing with ambiguous references like they or that. Being able to grasp context is crucial for conversational assistants to facilitate natural communication between users and agents. Additionally, allowing users to ask about what they see on their screen is vital for a hands-free experience with voice assistants. Different types of context, such as conversational and on-screen context, play a key role in handling user queries effectively. While large language models, LLMs, have made end-to-end experiences possible, there are still scenarios where a traditional multi-stage pipeline is necessary. For instance, on devices with limited computing power like smartphones, using a single large end-to-end model may not be feasible due to efficiency and latency constraints. Integrating with APIs or handling upstream and downstream components also requires a more structured approach than an end-to-end model can provide. Reference resolution, which includes identifying conversational references as well as on-screen entities, remains important despite advancements in large language models. We propose using smaller language models specifically fine-tuned for reference resolution tasks. Language models have shown promise in various tasks like causal reasoning and question answering, but resolving references to on-screen entities poses a unique challenge. Our approach involves reconstructing the screen using parsed entities and their locations to create a textual representation that helps the language model understand the context. While traditional reference resolution systems have focused on conversational and visual references, resolving on-screen references is an area that requires more exploration. Jointly handling conversational and on-screen references is crucial for natural interactions with mobile devices. Existing models trained on natural images may not perform well on synthetic screens, which have a different distribution. Our work aims to address the limitations of previous approaches by focusing on on-screen references and avoiding the need for complex visual understanding modules. By leveraging language models and textual representations of the screen content, we aim to improve the accuracy and efficiency of reference resolution tasks in voice assistants. Section Summary. In this section, we delve into the importance of understanding context in human speech, especially when dealing with ambiguous references like they or that. We highlight the necessity of incorporating conversational and on-screen context in conversational assistants to enable seamless interactions. Additionally, we propose a method that uses parsed entities and their locations to create a textual representation of the screen for reference resolution, a novel approach that aims to enhance the capabilities of large language models in understanding on-screen context. Section: Task. In this section, we formulate our task as follows. Given relevant entities and a task the user wants to perform, we aim to extract the entity or entities that are important for the current user query. The relevant entities fall into three categories: on-screen entities, conversational entities, and background entities. On-screen entities are those currently visible on the user's screen. Conversational entities are relevant to the ongoing conversation, which could be from a previous user turn or provided by the virtual assistant. Background entities are important entities from background processes not directly visible to the user. We present the task of reference resolution as a multiple-choice task for the LLM, where the goal is to select one or more entities displayed on the user's screen as the output. The model is allowed to output the relevant entities in any order, and we consider any permutation of the correct entities as a valid answer. Our datasets consist of synthetic data and data annotated by human annotators. Each data point includes a user query, a list of entities, and the ground truth entity, or entities, relevant to the query. The entities contain information about their type, name, and other textual details. For data points with on-screen context, we provide the bounding box of the entity and information about surrounding objects. In conversational data collection, graders are shown synthetic lists of entities and asked to provide queries that clearly reference a specific entity in the list. For synthetic data, we generate data from templates, particularly useful for type-based references. The data generation process involves base and language templates to create queries by substituting references with mention and slot values. On-screen data is collected from web pages containing contact information. The annotation process involves extracting queries based on screens and identifying entities and mentions. Graders classify data from screenshots into entities and provide queries related to the identified information. This process helps in understanding how users refer to entities visible on their screens. Section Summary. In this section, we formulate our task as extracting pertinent entities based on user queries, which can be on-screen, conversational, or background entities. We present the task as a multiple-choice problem for the LLM, allowing the model to output relevant entities in any order. Our datasets include synthetic and annotated data points containing user queries, entities, and ground truth relevant entities, with additional context like bounding boxes for on-screen entities. We also collect conversational data by asking graders to reference specific entities from synthetic lists, and generate synthetic data using templates for type-based references, enabling the resolution of multiple entities for a single reference. Section: Models. In this section, we compare our proposed model ReALM with two baseline approaches. The first baseline is based on a system from a previous study called MARS, which focuses on different types of entities. The second baseline involves using ChatGPT, specifically the GPT 3.5 and GPT-4 versions, for predicting entities in a given context. For the MARS baseline, we re-implemented the system using datasets that include conversation, on-screen, and synthetic data. Unlike our approach that uses a pre-existing large language model, LLM, this baseline system was specifically designed for reference resolution tasks. Regarding the ChatGPT baseline, we utilized both GPT 3.5 and GPT-4 versions within context learning. We fed the models prompts to predict entities, with GPT-4 having the additional capability to analyze images for on-screen reference resolution, which improved its performance significantly. Our approach involves fine-tuning an LLM, specifically a Flan T5 model, by providing parsed input and training it without extensive hyperparameter search. We convert user queries and corresponding entities into a format suitable for LLM training, ensuring the model does not overfit to specific entity positions. In terms of results, our approach outperforms the MARS model across all datasets and even surpasses GPT 3.5, which has many more parameters. Despite being a lighter and faster model, our approach performs comparably to the latest GPT-4, especially excelling in on-screen datasets. Experimenting with models of different sizes showed performance improvement, particularly noticeable in complex on-screen datasets. In our analysis, we find that ReALM is comparable to GPT-4 and excels in new use cases like alarms. ReALM and GPT-4 perform similarly in unseen domains, showcasing the LLM's ability for complex natural language understanding. ReALM also outperforms GPT-4 in domain-specific queries due to its fine-tuning on user requests, demonstrating better comprehension of specific contexts.